Hi, third grade. Well, yesterday I went up to do the math lesson on the smartboard and I had straws cut and everything, and I did the lesson, and now I can't find it. I must have deleted it somehow. But you've seen me around technology. I'm not the greatest. But anyway, we're just going to go ahead and work through this lesson together. And it's on triangles. And we're just going to kind of introduce it, and you don't even have to send me the your finished work. We'll just go through this together so that you kind of get an introduction. And on page 735, I had some straws out, and what we found out was that the two shorter straws have to be as long as the longest straw when you put them together. And if you want to get your straws out, I sent some straws home in a plastic bag. And if you still have those, you can get those out and kind of play around with making triangles. Now, triangles are a type of polygon. They are a plane figure, closed, and made up of line segments. Okay, plane, closed, line segments. Tri, we know from Holy Trinity and tricycle. Tri means three angles. So every triangle has three lines or sides and three angles. So when we go on to page 736, it says there are two ways to describe triangles. There's a lot more than that. There's these big words like scalene, isosceles, right, obtuse, acute. But you don't have to worry about those today. You'll get those fourth and fifth grade. So this is just to kind of introduce to you. So you see the triangles at the top of the page up here. And two ways triangles can be described. Look at where it says one way. We can describe by the number of sides that are of equal length. So in the first picture, letter A, it appears that all three sides are equal. So we would match that dot to this descriptor. Three sides are equal in length. And just for those of you who want to know, that's called an equilateral triangle. Look at letter B and E. It appears that letter B has two sides that are equal, the vertical and the horizontal, and letter E has two sides that are equal, the two diagonal sides. So we're going to match that with two sides are equal in length. Then we look at C and D. If we look at C and D, we can see that none of the sides are equal to each other. So we're going to match that with the first descriptor, no sides are equal in length. So we can use sides, but there's another way. We can use angles. Triangles can be described by the types of angles they have. So we're going to do this matching activity again. So look at letter C. Look at the blue arrows. That angle is more than 90 degrees. It is greater than a right angle. So we're going to match that to the middle descriptor. You can only have one angle greater than 90 degrees in a triangle. So when you see that, we automatically know that that is an obtuse angle, obtuse triangle. Don't worry about that. You'll get to those words next year. Look at A and E. When we look at the arrows, we can see that they're not 90 degrees. They're a little less than 90 degrees. So those 2 would be connected to the last descriptor. 3 angles are less than a right angle. Those are acute triangles. So that means B and D. Let's see. Do you see that symbol? That little blue square? That means those are right triangles. So we would match that with the first descriptor that says one angle is a right angle. Okay, let's turn the page. I left my book up at school because I thought, oh, I'm done with the math book. I can just leave it up here at school. Luckily, I still have my manual, my teacher's book. Okay, at the top of page 737, it says, write the number of sides of equal length the triangle appears to have. And it looks to me like 2 of those sides are equal. So I would write 2 on that line. Now we're going to look at triangle F, G, and H. Which of those triangles has one right angle? Well, if you look at the symbol, you know right away that triangle F has one right angle. It makes the little square. Number 3, which triangle has one angle greater than a right angle? So here's a right angle. It's greater. It's more open. It's more open. G does not look like. Oh, the top angle in H. Look at that. That is number 3, triangle H. So that means triangle G has 3 angles less than a right angle. Every one of their angles is less than a right angle. Do you see how that's less? It's right now. It's less. Okay. Number 5 says, and we're using K, L, and M to complete the sentences. Triangle this has one right angle. Oh, you know what that is. That's triangle M. And it appears to have how many sides of equal length? Look at it. It appears to have, triangle M. We can see it's a right angle, and we see this horizontal and this vertical line are equal to each other. 2 sides are the same. So we're looking at both sides and angles. Triangle M has one right angle and appears to have 2 sides of equal length. Look at number 6. This triangle has 3 angles less than a right angle. Ooh. Well, when I look at this, I look at letter L, and this is less, this is less. Oh, but this one, that's more. So it can't be letter L, it must be K. And if I look at all 3 angles, yes, they are all less than 90 degrees. So triangle K has 3 angles less than a right angle, and it appears to have how many equal length sides? All 3. That's that equilateral triangle. Number 7, that means triangle L has to be the one that has an angle greater than a right angle. And how many sides appear to be equal? 0. No sides appear to be equal. Okay, so now we're going to go on to our lesson, and we'll work through this together. Okay. It says, use the triangles 1, 2, and 3, or for 1, 2, 3, and write A, B, or C, and then complete the sentence. It's just like what we just did. Triangle blank, oh, they did that one for us. So triangle B, look at it, has 3 angles less than a right angle, and it appears to have 3 sides of equal length. That's that equilateral triangle again. So we're done with B. We can just cross that triangle right off. Look at number 2. Which triangle has one right angle? Oh, there's a symbol for it. We know that's triangle C. So put C on the blank. Triangle C has one right angle and appears to have how many sides of equal length there? I don't see any. I'd put a big 0 there. Triangle A is the only triangle left. Let's see, does it have one angle greater than a right angle? It does. And it's the bottom corner. Let's see, right here. This angle is a little wider than 90 degrees. And it appears to have how many equal sides, equal lengths? It looks like 2 of those sides are equal. Number 4, Matthew drew the back of his tent. How many sides appear to be of equal length? So we're only looking at the back of the tent. We don't need to worry about this over here. So we're looking at the back of the tent. It looks to me like there are 2 sides. Number 5, Sierra made the triangular picture frame below, shown. How many angles are greater than a right angle? Do you see any that are greater than a right angle? Greater than right? I see 3 that look like they're less than a right angle. I would put 0. Let's go on to number 1 on the next page. How many angles less than a right angle does this triangle have? So are any of those angles less? Are any of them greater than? It appears that all 3 angles are less than a 90 degree or right angle. Number 2, how many sides, now we're talking about sides, of equal length does this triangle appear to have? It looks to me like the horizontal and the vertical sides are equal. 2 of them, 2 sides. Now, number 3 says, a quadrilateral has 4 right angles, 2 pairs of sides of equal length, 2 pairs of sides that are parallel. The pairs of opposite sides are not the same length. Looks to me like they're describing a rectangle or a trapezoid. Number 4, Mason drew a quadrilateral with only 1 pair of opposite sides that are parallel. So maybe the top and the bottom were parallel, and then this, so this is parallel with the bottom, and then this was not parallel with this side. That looks to me like a trapezoid. It was much better on the video. Okay, number 5. Draw a rectangle that has an area of 8 square units and a perimeter of 12 units. What are the side lengths of the triangle? I'm going to grab a pencil. We're going to do this one together. It was so much better on the video, but I'm going to draw this to start with. And when I look at this, I'm going to write down how many are in the perimeter and how many are in the area. So the area fills up the whole space. So that's 1, 2. We have an area of 2. What's the perimeter? Remember, that's the outside edge. Let's count it together. 1, 2, 3, 4, 5, 6. Perimeter of 6. But that's not what we need. We need an area of 8 and a perimeter of 12. Let's add 2 more to that and see what we get. So now I've got for my area 1, 2, 3, 4. Area of 4. What's our perimeter? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. All right, what should we do? Let's add on another pair of squares or units. Let's shade those in. So we have 1, 2, 3, 4, 5, 6, an area of 6. What's our perimeter? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We're getting close. Do you think the next one might be the charm? It might be the 1. Let's add 2 more units. Okay, add 2 more units just like I did. Let's count the area. 1, 2, 3, 4, 5, 6, 7, 8. So now we have an area of 8. Let's write that down. What's the perimeter? Let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We did it. We have drawn a rectangle that has an area of 8 square units and a perimeter of 12 square units. Look at number 6. What fraction of the square is shaded? Well, first we want our denominator, our bottom number. That's the total number of triangles in that square. So let's count all the triangles. 1, 2, 3, 4, 5, 6, 7, 8. A denominator of 8. That goes on the bottom, right? Denominator on the bottom. How many are shaded? 1, 2, 3. So we say 3 out of 8, or 3/8. There, that wasn't so bad. That was pretty easy for our last day of math.